Today, I'll be doing the iodine clock reaction. I'll be conducting this experiment in two ways, one using sodium thiosulfate for its thiosulfate ions, and one they could do at home using vitamin C, also known as ascorbic acid. Simply put, the iodine clock reaction is a reaction where you combine two clear-looking solutions and after a short amount of time, the solution suddenly turns a striking blue-black color. The time difference is what makes this a clock. Typically, the two solutions that are used for this reaction are a solution A that has a reducing agent such as thiosulfate ions or ascorbic acid, and a solution B which contains hydrogen peroxide. Along with this, starch can be added in either solution as I'll demonstrate later. Additional ingredients may be needed depending on which type of iodine clock you are making. The iodine clock functions because of three reactions. In the first reaction, iodine is turned into iodide ions and acidic protons due to the reducing agents of, for example, ascorbic acid or thiosulfate. In reaction 2, hydrogen peroxide reacts with the iodide ions and the acidic protons to make iodine and water. These two reactions effectively cancel each other out, recycling the iodine while draining ascorbic acid and thiosulfate, meaning over time, the reducing agent will run out. Finally, in reaction 3, after the reducing agents are used up, the iodide ions and iodine react to create triiodide ions which form complexes with the starch, creating the striking dark blue-black color we see. In the first iodine clock, I'll be using a modified recipe from a Neo-Sci iodine clock investigation kit. To begin, I'll start by measuring out 1.21 grams of cornstarch and 168 milliliters of vinegar to create an acetic acid starch solution. Afterwards, I added around 0.83 grams of sodium acetate that I synthesized for my last video. Then I mixed it. Afterwards, I added 0.55 grams of sodium thiosulfate that I ordered online. This is used for the thiosulfate ions that will act as a reducing agent later on. Next, I measured out 1.5 milliliters of iodine tincture. This is our one and only source of iodine for the iodine clock. And I made a mess, so let me quickly clean that up. Next, I added the iodine tincture to our solution of what is now acetic acid, cornstarch, sodium acetate, and sodium thiosulfate. It dissolving and not showing any color is a good sign. Finally, it is time to begin the iodine clock. Along with 50 milliliters of our solution A, I added 20 milliliters of our solution B, which here is just hydrogen peroxide. Around a minute and 30 seconds later, the timer finally finished. Because hydrogen peroxide didn't equally react with all areas of the solution at the same time, you can see the blue starch complexes forming throughout and spreading across the solution over time. Fun fact, you can actually make this reaction work in the opposite, as we can introduce thiosulfate ions once again using sodium thiosulfate. Here I added 0.28 grams and then 1.01 grams. And you can see over time the solution returning back to the cloudy white of before. And then after even more waiting, you can see the solution redo the iodine clock as the thiosulfate is used up. And that's that for Iodine Clock 1. But now I'll teach you how to make your own iodine clock at home. Some ingredients you could have laying around could be the iodine tincture and hydrogen peroxide, but also vitamin C and cornstarch. Additionally, I have distilled water in the background, but tap water should work just fine. And lastly, the coffee filter. To begin, we'll be crushing up 1,000 milligrams worth of vitamin C tablets. Here, I only have 500 milligram tablets, so I'll be crushing up 2. But if you have a 1,000 milligram, you only need to crush up 1. Then, I'm going to add 60 milliliters of distilled water and mix until dissolved.
Wow, it smells like oranges.
Afterwards, I'm filtering the solution through a coffee filter and funnel. While I waited for the solution to filter, I began preparing the 12.5 milliliters of iodine tincture needed. Just like before, the disappearance of any coloring of the iodine tincture when hitting the reducing agent is a good sign. To finish this solution, I just topped it off to around 500 milliliters. Next up is the hydrogen peroxide and starch solution. To begin, I added 0.4 grams of cornstarch to a beaker and around 350 milliliters of distilled water. Then, I dissolved the cornstarch by heating it until it boiled, and then I filtered the solution. Finally, I added around 150 milliliters of hydrogen peroxide. And there, both of my solutions are done. Time for the iodine clock. For my first clock, I added equal amounts of each solution with 40 milliliters to each. A minute and 30 seconds later, the complexes began to form. I did the same thing for my second iodine clock, except this time I recorded it from above. Two minutes and 30 seconds later, the timer had stopped. For my third reaction, I decided to pour in the same amounts of the solutions, but this time change the order with the hydrogen peroxide starch going in first. Four minutes later, the reaction began occurring. In retrospect, I think there were a few flaws with me going back to back to back with all these iodine clocks, as Temperature is a major factor in how fast the reaction occurs, and because the first few clocks were when the solutions were hotter, that just meant that they were going to react quicker. So from now on, the reactions began going slower. Anyways, for this one I also used equal amounts, but this time only 15 milliliters of each solution. Five minutes later, the reaction began. It was most definitely much slower though. As an additional side experiment, I decided to add thiosulfate into this iodine clock, and well, I overestimated how much I actually needed. I ended with just a huge clump of thiosulfate in the corner, and if I let the reaction proceed, which over time it would use all of it, I just thought I'm not waiting weeks for this to finish. For my last one, at this point everything had cooled down by now, but I decided to add 30 milliliters of the starch hydrogen peroxide solution and 60 milliliters of the iodine solution. Six minutes later, the iodine starch complex began to form, but this time, the solution looked much more purple than usual.
Purple?
My guess was, due to the excess iodine ions that I added, some of the iodine was turning into I2 in the solution and giving off a more purple look, as iodine gas does look purple. Anyways, thank you for watching this video and hope to see you in the next one. Cheers.